This is Dr. Bitla Venu coming in front of you in continuation to my uh, previous sessions. As my knowledge, this is my 24th session in Fundamentals of CAD CAM subject. In our last session, we have discussed regarding the FMS flexible manufacturing systems. Then we are also discussed about the automated guided vehicles, types of automated guided vehicles, advantages, disadvantages of FMS. Then we are also discussed about the automated storage and retrieval systems, CS and RS systems, the terminology related to the ASRS. All we are discussed, and now let me move further to discuss some of the contents related to the robotics and classification. In this session, we will discuss robotics and robots introduction to industrial robots and what is the classification, how the robots are classified. We will classify in this session. Then we move forward to see the what are the components of the robot and what is degrees of freedom. Then finally, we will see the advantages, disadvantages of the robots in while using robots. Then we will also discuss the roles of robots in industry. In this session is going to cover all these contents. So let me move further to see the content of introduction to robots. Basically, robots are used to increase the efficiency of the plant. Example, you take in any of the industry, there are some instances, there are some cases in which human cannot enter, human cannot work. So in those situations, especially in 1970s and 80s, the robots are preferred where the humans cannot intervene, humans cannot work. Like you take the furnaces interface, a furnace environment or high temperature environment where human cannot enter. It does. I mean, in those instances, robots are preferred. In 1970s and 80s, the evolution of robots was started. I mean, initial stages. I mean, basic robot was started designing from 1970s onwards. But in an industrial aspect, industrial point of view, uh, the used one, I mean, the robots are used, as I said just now, where the human cannot. But the robots usage is evolved from basically in the starting stages, NC was used, CNC was used, later computer-aided design, manufacturing. Then we have seen the computer integrated manufacturing. All these we have seen, and after coming all these stages, then we have the robots. So basically, robot is one device or one mechanism, one programmable mechanism which can work according to the instructions, according to the instructions of the program. This is what we will define the what exactly the robot in the coming slides. But as I said just now, robots are also well suited for doing a heavy, dangerous, and repetitive task. This is, I mean, wherever we want to repeat the task, human can do some mistake. But wherever human cannot enter, and the dangerous environments are heavy duty, I mean, these are the instances or the situations where we can use industrial robot. Then since the robot replaced human workers, the organized labor resisted the move by the major companies because there are some disadvantages. If you use robot, that reduces the uh, that increases the unemployment. This is what there are some advantages, but in turn we have some disadvantages. But in comparative the disadvantages, but the advantage is more because due to the evolution of the industry, we need to adapt the technology. Okay, but in the initial stages, one simple robot is we need to spare for thousands of dollars. But even in turn, the technology is growing up. But nowadays, where we can purchase the robots in an affordable price. This is what the latest, I mean, in the latest developments also, even you can see the COVID in this pandemic situation also, robots are used to serve the patients in hospitals. Everywhere the robots are used in across the globe in this pandemic situation also. So according to the customization, according to the usage, robots are designed and used. But as of now, I can say that the robots are available, commercially available in the market in the affordable price. This is what, according to the customization we have, according to the domain usage, the robots are designed and supplied by the suppliers or by the manufacturers within the affordable price. This is what the robots are available in the market. But we have but basically, why do we need to use the robots? Basically, there are some reasons. So we will see few reasons to use robots in industry. Is robots never get sick. This is one advantage. Robots never get sick or need rest, because as a human being we must go to, I mean, we must have some fatigue. So to avoid that fatigueness, so robots never get sick, and even human being can take rest and after, I mean, casual leaves and all those. Because if it is a robot, it doesn't require the leaves, it does not have sick at all, and it doesn't require rest at all. So it can work 24 by 7 in a week. This is the reason why we require robot to get uninterrupted production in the manufacturing industry. The other reason is that when the task required would be dangerous for person, as I said just now, the task to be performed is very, very dangerous, where the human beings cannot perform those tasks. In that case, robots are useful. Then the other reason is that robot don't uh, get bored, because as a human being, if he goes on doing work continuously, the human beings can get bored. But if it is a mechanism like robot, it does not get bored. So it can perform repetitive work. This is what the advantage of the robot. Then when it comes to the definition of the robot, robot is a reprogrammable manufacturing machine, reprogrammable manufacturing machine designed to manipulate materials, parts, tools, and specialized devices through the variable programmed motions for the performance of variety of tasks, to perform variety of tasks. Robot is a reprogrammable multifunctional mission, reprogrammable multifunctional mission designed to manipulate materials, parts, tools, or specialized devices through the variable programmed motions for the performance of variety of tasks, or to perform variety of tasks. So this is what exactly the definition. Robot is a reprogrammable multifunctional machine. Reprogrammable multifunctional machine designed to manipulate materials, parts, tools, specialized devices through the variable programmed motions for the performance of variety of tasks. This is what the definition. Then it can also be defined in different way. That is, an industrial robot is officially defined by an automatically controlled reprogrammable multi-purpose manipulator, programmable in 3 or more axes. uh, Automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes. These two are the very, very important definitions and commonly used, commonly defined robot definition. Simply you can say that robot is a reprogrammable multifunctional machine. Multifunctional means it can perform a number of functions like holding, carrying, then moving, and all these can be used. Multifunctional. So more than one function a robot can perform. So it is a reprogrammable means you can modify the motions of the robot. You can change the functionality of the robot according to the, by varying the program. Reprogrammable multifunctional machine. Okay, so please, these two terms are very, very important with respect to the definition of the industrial robot. Now, when it comes to the degrees of freedom, so this is one of the classification of the industrial robot. I mean, industrial robots are also classified according to the degrees of freedom. So we will see how we are going to classify while discussing the classification of the robots. But before going to that, then what exactly the degrees of freedom? So degrees of freedom means are specific uh, degrees of freedom in a mechanics context are specific defined modes in which the mechanical device or system can move. Specific defined modes in which mechanical device or system can move. That means we have a machine that is having specific defined modes of motion. That means it is designed to perform, designed to move in a specific mode is nothing but degrees of freedom. The number of degrees of freedom is equal to the total number of independent displacements or aspects of motion. So how many number of motions that a machine can have, that means we can say that is nothing but those many number of degrees of freedom. Example, to take a machine can move, a table can move horizontal and as well as vertical axis. That means the degrees of freedom of the table is 2. Even if that a table can rotate in 360 degrees, then we can call that table is having 3 degrees of freedom. 2 are linear and 1 is rotational. So how many number of specifically defined motions a machine can have, predefined motions a machine can have, those are nothing but degrees of freedom. So the term is widely used to define the motion capabilities of the robot. As I said just now, uh, whenever we want to specifically speak about the motion capabilities of the robot, so we definitely consider, with the primary criteria to be considered is degrees of freedom. Robot arms are described by their degrees of freedom. As I said just now, all the arms are defined basically according to the degrees of freedom. That means an arm can move how many degrees, how many motions that arm can move. Normally, robot is having one manipulator. In turn, we can also call that as arm. We will discuss what is manipulator and what is end effector and what are the components in the coming slides. As of now, you try to remember that uh, degrees of freedom is nothing but specific defined modes in which a mechanical device or system can move. Please remember that. So specific defined modes in which a mechanical device or a system can move is nothing but degrees of freedom. So degrees of freedom, DOF, in short, you can call it as degrees of freedom, is specifically to configure, to speak about the value used to define the motion capabilities of the robot. DOF is to define specifically the robots or the motion capabilities of the robot. So let me move further. This is number specifically refers to the number of single axis rotational joints arm, where the higher number of, okay, we will discuss what exactly in the coming slides. So now when it comes to the classification of robots, you can see here. So robots can be classified according to the various criteria. So one is, as I said just now, the first classification is according to the degrees of freedom. Specific defined motions of a device or a system is nothing but degrees of freedom. Specific defined motions of a machine or a system is nothing but the degrees of freedom. As I said just now, a manipulator means as of now, you remember that manipulator is nothing but the arm of the robot. Okay, a manipulator should have 6 degrees of freedom to manipulate an object freely in 3-dimensional space. So normally, any of the manipulator can have 6 degrees of freedom: 3 linear along x, y, z axis, and the 3 rotational along the x, y, z axis. So these 3 are these three linear motions and three rotational motions. So totally a mission, a device can have 6 degrees of freedom. So 6 motions, 3 linear, 3 rotational. So 6 degrees of freedom robot can be observed here. Now you can see. So we have 3 linear motions. One, so first linear motion, second linear motion, and third linear motion you can see here. So then you can see one rotational, and you have another rotational, you have other rotational. So totally a robot can have 6 degrees of freedom, 3 linear and 3 rotational. So this you can see here. Okay, so we will see what are the elements of the robot later. We will see. Okay, so classified. So one of the classification of the important classification of the robot is according to the degrees of freedom. So under this classification we have general purpose robot, redundant robot, then we have the deficient robot. General purpose robot means if it possesses 6 degrees of freedom, so we can call that as the general purpose robot. That means a general purpose robot is having 6 degrees of freedom, 3 linear and 3 rotational. Then a redundant robot means if any of the robot which is having more than 6 degrees of freedom, we can call that as a redundant robot. Okay, then if any of the robot is having less than 6 degrees of freedom, we can call that robot as deficient robot. So under this classification, under the class, I mean, the robots are classified according to the degrees of freedom. So under that, we have basically three types of robots. It can be general purpose, in which we have, or that type of robot can have 6 degrees of freedom. Then there is another robot called the redundant robot. The robot which can have more than 6 degrees of freedom is nothing but redundant robot. Then we have the deficient robot, in which the motions of the robot or degrees of freedom is less than 3. So these are the three types of robots that we can, I mean, commercially available outside under this classification. Okay, so let me move further to see what is another classification. So robots can also be classified according to the kinematic structure. So kinematic structure, I mean, according to that, we have three types of structures. One is open loop structure, the other one is closed loop structure, then we have the hybrid type of structure. So serial robot or open loop structure is said to be a serial robot or open loop robot if it is kinematic structure takes the form of open loop chain. That means, so the start point is not connected to the end point. So this type of robot is nothing but open loop manipulator or open loop kinematic structure robot. Then we have the closed loop manipulator or closed loop kinematic structure robot, in which the start point of the manipulator is connected to the end point. That means closed loop structure we have. Then hybrid means hybridizing open some extent and some extent closed is nothing but hybrid manipulator type robot. So under this classification, basically we have three types: open loop, closed loop, and hybrid type. So open loop manipulator, closed loop manipulator, or parallel in turn you can call, and the other one is hybrid manipulator. So the combination of open and closed loop. So this is the second classification. The first classification is according to the degrees of freedom. The second classification is according to the kinematic structure. The third classification is according to the type of drive. According to this category, it can be electric drive if the manipulators or the mechanisms, all the movements are taking the input energy, electric drive using the electric motors, electric drives. So that is according to the drive technology. It can be electric type, it can be hydraulic type, it can be pneumatic drive. All the mechanisms, all the levers, all the motions, if we get from the energy source is from the electric type, so then we can call it as electric drive. If a robot is using electric drive to actually, I mean, to use all the, to get all the motions, then we can call that as the electric drive robot. Suppose if the motions in the robot is getting using the hydraulic mechanism, then we can call that robot as hydraulic type of mechanism or hydraulic drive mechanism. If any of the robot is using or getting the motions from the pneumatics or the compressed air, then you can call that drive robot as a pneumatic drive robot. So according to this classification, I repeat that it can use electric drive, it can use hydraulic drive, it can use pneumatic drive. This is the third classification. When it comes to the classification by the workspace geometry, that means in what workspace the robot can be controlled. In which workspace geometry, our tool can move. Now, according to this classification, it can be Cartesian, it can be cylindrical, or it can be, we will see, okay, a classification according to the workspace geometry. Now you can see it can be a Cartesian robot. That means in this, the kinematic structure of the robot arm is made up of three mutually perpendicular prismatic joints. So that means three mutually perpendicular prismatic joints. The entire structure of the robotic arm is made up of three mutually perpendicular prismatic joints. That means three Cartesian coordinates associated with the three prismatic joints can conveniently describe the twist center position of the Cartesian robot. That means we will see this in the next figure. You can see Cartesian robot looks like this. It is the basic block diagram of the Cartesian robot, in which you can see the motions are in the Cartesian manner along the three axes. So y-axis, x-axis, and z-axis. That means, so we have only the robot can be controlled only three Cartesian coordinates, three mutually perpendicular principal axes. So that type of robot is called Cartesian robot. The workspace geometry of this type of robot is rectangle. So in a rectangular coordinates only, we can adjust, we can move the robot. Robot is having only a rectangular workspace geometry. That's why we are calling this as Cartesian robot. Okay. So then we will see the next other type of robot is that cylindrical robot. So a robot arm is called cylindrical robot, either of the first or second joint. Basically, in this case, we have seen three joints. So in this case also, there are three joints, and the first joint or second joint is of Cartesian robot is replaced by the revolute joint. Revolutionary, I mean a revolve type of joint. Then that type of robot is called the cylindrical robot. Basically, in Cartesian robot, we have seen three joints, three linear joints. Okay, three mutually perpendicular prismatic joints. In these three mutually perpendicular joints, the first one or second one can be replaced by a revolute joint. So then that will become cylindrical robot. So the workspace geometry of this cylindrical robot is the concentric cylinders. So the two concentric cylinders of the the finite length confine the workspace geometry of the cylindrical robot. Two concentric cylinders will become two concentric cylinders will confine the movement of the workspace geometry of the cylindrical robot. So this type of robot, as we can see in the next slide, is you can see. So you can see basically in this case we have three mutually perpendicular prismatic joints, but whereas here you can see one joint is revolutionary joint. So the two are one is replaced by the revolutionary joint. As you can see, the other two are the linear movements, the other one is rotational. So two linear, one rotational, this will become cylindrical. So two concentric circles will confine the workspace geometry of the cylindrical type of robot. And then we have the spherical type of robot, in which case, as you can see, this is an alternative version of the cylindrical robot. The first one we are already, changed as a revolute one. If the second one is having the rotational motion along with the prismatic motion. In addition to that, if it is having the rotational motion, then it will become spherical robotic type motion, spherical robot, as you can see. So the two cylindrical two spherical cylinders, two concentric spherical cylinders will confine the spherical geometry, spherical coordinate geometry, or the spherical workspace geometry, or the workspace geometry of the spherical robot. Two concentric spherical balls will confine the workspace geometry of the spherical robot. In turn, you can call in that way. So that we are calling the first one is prismatic as it is, and the second one we are replaced with the, we are giving the rotational and as well as oscillating, as we have seen. The third one we kept as it is, that is having the prismatic motion in the case of spherical robot, as we can see in the figure. So this is the modified version. The spherical one is the spherical robot is the modified version of the cylindrical one. As you can see, it is having the rotational and as well as the oscillation. So only one linear motion, you can see one translatory motion. So initially we have three linear motions, and in the cylindrical one we have two linear and one rotational motion. In the third one we have the uh, the other linear motion is replaced with the oscillatory motion, then it will become the spherical workspace geometry robot. Okay, so then we have the other type of robot. The other one is the articulated robot. So articulated robot is said to be an articulated robot if all the three joints are of revolute type. So in the first case, as you can see, all the coordinates are prismatic. That means x, y, z axis only linear motions. In the case of cylindrical, two linear and one rotational. In the case of spherical robot, so one linear, one rotational. In addition to the rotational, it is also having the oscillatory motion. So that will become the spherical robot. Then we have the articulated robot, in which uh, uh, the arm is said to be an articulated robot. All the three joints are of revolute type. So then it can be called as articulated robot. If all the three joints are of rotary type or rotational motion, then we can call that as articulated robot. So we will see what is articulated robot in this figure. So this is exactly the articulated robot. All these are having the rotational motion. So you can see. So at this location we have rotation, at this location we have, and everywhere you find the rotary motion, then that type of robot is nothing but articulated revolute or the jointed spherical robot. Then we have the final type of robot, that is the SCARA robot. The SCARA stands for Selective Compliance Assembly Robot Arm. Selective Compliance Assembly Robot Arm. So it is special type of robot consisting of two revolute joint followed by one prismatic joint, as you can see here. So two revolute and one prismatic. So this is one type of robot, SCARA. Uh, Selective Compliance Assembly Robot Arm, SCARA, is a special type of robot, and as I said just now, it have two revolute joints followed by one prismatic. You can see, so two revolute and one prismatic. Okay, all the three joints are of parallel, joint axes are parallel to each other, and actually point along the direction of the gravity. Okay, so all the three joint axes are parallel to each other and usually point along the direction of the gravity. Okay. So the wrist axis has 1 degree of freedom. As you can see, the wrist axis is having 1 degree of freedom. Okay, hence the entire robot has 4 degrees of freedom. Yes, they have 1 degree, 1 degree, 2 degree, and it has a one more. So totally 4 degrees of freedom. So this type of robot is useful for assembling parts in a plane. Assembling of parts in a plane. In a plane, if we want to perform assembly action, so that this type of robot is useful. So these are the different types of robots that we can come across outside. according to the workspace geometry. So then we have other classification is by according to the motion characteristics. As I said just now, planar, spherical, then we have planar, spherical, and we have Cartesian, then the spatial. So first you can in a plane, in one plane we can move, then in spatial, I mean spherical you can, then it can be according to uh, the spatial. Spatial means in any of the direction the robot arm can move. So this type of robot is also very, very important and used commercially outside. So now when it comes to the basic components of the robot, there are, I mean, a robot can have a definite number of, there are basic components. Other than this, of course, there are number of components, but in this slide, in this session, we will see what are the basic components required if we want to call that as a robot. So the first one is basically it must have a structure, and all the structure means all the links, which signifies that all the links base. It must have a very big base to control. It can withstand all the forces, to take the reactive forces, right? And this requires a great deal of mass. Of course, all the structures must be able to withstand all the forces while carrying the load or while performing the work. So the structure is also very, very important, and all the links, all the base, and all the joints uh, must be enough strength to withstand all the forces. Okay, then and also to ensure the minimum error. Okay, so the structure must have enough strength to withstand all the forces and to get the desired accuracy. Then the second component is the actuator. Actuator means actually what will be the source, whether we are using the motors, cylinders, so that drive the robot joints are nothing but the actuators. I mean, all the motions we will get from the motors and from the cylinders, etc. So that drive the robots. So which are called the robotors. Motors, cylinders are called the actuators. Okay. So this might also include the mechanisms for the transmission. Okay, our locking mechanism, or the transmission mechanism, all we can call as the actuators. Then we have other basic component, that is the control computer. Of course, because by the name itself we can say programmable machine is nothing but a robot. So we must require reprogrammable machine. We must require to program a computer also we require. Then in-arm tooling, the tooling is provided by the user and designed for the specific. In-arm tooling means a robot is having an arm, or in turn you can call it as a manipulator. At the end we have end-effector. So every robot is designed to work in a specific environment or for the specific purpose. In that case, the end of the arm must be designed in a specific purpose. So that is called end of arm tooling. Sometimes a robot is designed to perform the welding. Sometimes a robot is designed for painting. So like this number of applications, the arm of the tool must be designed for the specific purpose. So it is called the end of arm tooling. Okay. So then we have the tech pendant, and this is one popular method of programming the robot. This is a small handheld device, can direct motion of the robot. Okay, this is a small handheld device, can direct the motion of the robot. That means a small device. So by using that device, we are going to control the motions of the robot. So it is just like a compact device. Using that compact device, the motions of the robot will be controlled. That is called the tech pendant. Okay. So these are all the basic components of the robot. It must have structure, it must have actuators, it must have the control computer, it must have end of arm tooling, and it must have the tech pendant. Okay. So these are the basic components. So those components that we can observe in these slides. So as I said, we must have a computer, we must have the tech pendant is a small handhold device which is used to control the motions of the robot. Then we have we must require the actuators like motors, drives. Basically drives are nothing but the actuators. Then mechanical arm means we must have a structure. Then indam tooling, EOAT we must require, and this must be designed according to the environment in which we are using the robot. Then we must require the sensors, and computer must have memory. Then computers must have the PLC and NC machine to perform actual work. Suppose if our robot is doing something on the machine, it can be a NC machine or a PLC type. Okay, so one typical robotic manipulator that we can observe in this figure, as you can see, basically manipulator must have. Uh, so let us see the manipulator description in this slide. So robot manipulator is electronically controlled mechanism. Basically, it is electronically controlled mechanism. That means it must have PLC circuit. So according to that, this PLC or the program PLC is going to activate, and according to the work according to the program that we are getting from the source, computer source, or where we have the programs. Okay, so consisting of multiple segments, manipulator consists of multiple segments means links. Okay, that performs the tasks by interacting with the environment. As you can see, it consists number of links. Okay, number of arms or the links. By interacting all these links will be used to perform the actual work. That means this manipulator is going to interact with the work environment to perform actual work. Manipulator is also having the two links. One is major linkage, and other one is the upper linkage. Okay, major linkage or minor linkage. Okay, and you can have lower arm and upper arm. You can see major linkage consists the lower arm, link, base, and waist, and all motor, base, and all these are called the major linkage. Then on the upper arm, it is also having the upper arm where lower arm and upper arm is connected together using a joint. Of course, here also this upper arm can have oscillating motion. Then finally, the upper arm is connected to the wrist or the end effector, we can call, where actually this end effector is exposed to the atmosphere of the work zone. Okay. So this is actually the manipulator. This resembles the robot arm. Robot arm is nothing but robot arm is going to, manipulator is going to resemble the robot arm. In turn, we can call it as a robot arm. Okay. So this is the robotic manipulator with links and joints. Now let me move further to see what is how this manipulator is going to work. The actuator accomplishes the motion of the joints. Yes, actuator means it may be any of the drive, it may be a motor. This this manipulator is going to get the energy from the actuator. That means a drive, it can be a motor, and that motion will be transmitted from one link to another link, and finally the desired motion will reach to the end effector, where actually the device or the end part of the robot is going to be exposed to the work environment or interact with the work environment. So end effector is the device which is the final part or end part of the manipulator that exactly is going to interact with the one work environment. That is the end part of the manipulator that is going to interact with the work environment. So that we are calling it as end effector. So we will see the different types of end effectors in the coming slides. So this is actually the working of the manipulator. As I said, manipulator is going to receive the energy from the actuator, and that energy, that motion will be transmitted from one link to another link, and finally the motion will be reached to the end effector, which is exactly going to interact with the work environment. This is exactly the working of the manipulator. Then we will see the end effectors. In robots, an end effector is a device basically at the end of the robotic arm designed to interact with the environment. As I said just now, end effector is a device at the end of the robotic arm. As I said just now, this will be the end part of the robotic arm or the manipulator specifically designed to interact it is designed to interact with the work environment. Suppose the end effector needs to work in the furnace, so the design of the end effector is different. If the end effector is designed to work in the chemical industry, directly that end effector is going to interact with the chemical. The design of the end effector is different. So in which environment the end effector is going to work, based on that the end effector will be designed, and this will be the end part of the robotic arm or the manipulator. This is called the end effector. So the end effector is mounted on the wrist, as we have seen in the last slide. Let us see. This is the end effector. As you can see, this is the end effector, and this is actually exposed to the atmosphere or the work environment. Okay, so let me move further to see. Uh, End effectors are basically categorized into two major groups. So those are grippers and the tools. So end effectors are basically categorized into two groups. So those can be grippers and the tools. As you can see, it can be called as a gripper, it can be called as tool. So grippers means basically grippers are used to hold the workpieces. That's all. To carry the loads from one location to another location, or while performing work, sometimes the robots can also hold the work. Okay, and the robot end effector can also be used directly as a tool. Like you can see, if the robot end effector is designed to perform the welding operation or the painting operation, it is designed in such a way that, okay, so it can be used as a tool, it can be used as a drilling tool, it can be used as a painting, it can be used as welding. So we will see the different types of tools in the coming slides. So as of now, the grippers are used to hold the workpieces, whereas the tools are the will become the direct part of the I mean, with the help of those tools directly, so we will perform the work. Basically, grippers are three types. One is the mechanical grippers, vacuum grippers, and the magnetic grippers. As by the name, we can assess that the mechanical mechanism is used to hold the workpiece. Whereas if it is a vacuum gripper, the low pressure is going to hold the workpiece. And if it is a magnetic gripper, the magnetic force is going to hold the workpiece or the desired component by the end effector. Okay, so these are the three types. So, okay, mechanical, vacuum, and magnetic type. Then we are also having a special purpose grippers, which can be adhesive grippers. So an end effector can have some adhesive material. I mean that with that also we can hold the workpieces. And the piercing grippers, component to be handled is pierced in that case. Then hooks, scoops, then scoops type, then other type of grippers, and all these are the special purpose. So I mean specifically that is designed to hold some special purpose. For example, an end effector is designed to carry the motors which is having eye bolt. So that design is different. Like that, it is designed to hold small size objects. In that case, we can use adhesive type. So all these are designed for the special purpose, so that we can call this or the special purpose. So now you can see some of the figures in this case. It can be an inside gripper. All these are mechanical grippers. Mechanical grippers can be inside, maybe outside. Inside grippers are used to hold the, I mean, hollow objects, and the outside grippers are used to hold the solid objects. As you can see, vacuum grippers, the vacuum pressure, the negative pressure is used here to hold the workpiece, as you can see here. So the upper portion of the component is component that is to be hold, that we need to hold, will be created, the vacuum to hold the actual component. Then you can see here we have a magnets here, whether it can be electromagnet or a permanent magnet, and with the help of the electromagnetic force also we can hold the components. That figure also you can see here. So end effectors can be the grippers, as I said, those can be the tools. So it can be, as I said, it can be, end effector can be directly used as a tool. As I said, it can be used as a spot welding, or it can be used as arc welding tools, or spray painting nozzles, or it can be rotating spindles for the drilling. It can also be, this tool can also be used, this robotic end effector can also be used as a rotating spindle for drilling, and it can be the rotating spindle for the grinding. So these are specifically designed tools used as the end effectors for the robots. Let me move further to see what are the applications of the robots. As you can see, applications of the robots are in welding side. We can see, we can, as I said, we can use the robots in the painting, we can use the robots in assembly, then palleting and material handling. You can use the dispensing operations, laboratory applications, water jet cutting. Then we can also use in the work cells. Okay. Then when it comes to the disadvantages of the robot, it increases the unemployment. Yes, it's a major problem. Once we use a robot, it is going to perform number of operations or multifunctions, multitasking, and 10 members work or the 20 members work can be approximately, I can tell you that this is going to replace number of human beings. So in turn, it increases the unemployment. In turn, it increases the productivity and accuracy. Okay, that is the advantage. But here we are discussing the disadvantage. So unemployment will increase. Then economic problem. Paying salaries. This is the one disadvantage. The robot operator, for the robotic operator, we need to pay more salary. That is also one disadvantage. Lack of capability to respond in emergencies. Of course, this robot is not going to respond emergencies. Sometimes a human being can think. Sometimes some situations will come as a human being, the machine need not work. We need to take the decision uh, in the situations where we come across the situations which cannot be controlled. As a human being, we need to think. So this robot cannot think as like a human being at the special situations are there. Then lack of decision making power. Of course, it is not having decision making power. It is a programmable one. Other than the program, the robot is not going to work. Then it is having limitations like degrees of freedom and skills, sensors, real-time response we require. And the cost is high, initial investment required is high. So needs the training personnel for programming, and all these are the disadvantages of the robot. So let me move further to see what is the role of robots in SIM. Robots role in computer integrated manufacturing is robots are going to encourage the marketing, order entry, then accounting. The robots are going to take care about the marketing, order entry, accounting, design, manufacturing, quality control, shipping, and all other departments to work closely together without the process. And all these are the robots, role of robots in computer integrated manufacturing. That means the robots are going to perform, are involved in these operations like marketing, order entry, accounting, design, manufacturing, quality control, and shipping. And all these activities will be taken care some extent by the robots. So this is the roles of robots in the sim. So thank you one and all, and this completes the robots and robots. Then in the previous session we have seen the FMS, ASRS, then AGVs we have seen in this chapter. So thank you one and all, and this completes the basic fundamentals of CAD CAM. So totally, since from the first chapter to the last chapter, that is the fundamentals of SIM, robotics, FMS, all we have seen, ASRS in this chapter. This completes the fundamentals of CAD CAM. And all these contents are specified according to the textbook, that is Fundamentals of CAD CAM by Dr. Bitla Venu, that is myself, written, and the contents are specific, and the contents are this book is written specifically suits to the engineering subjects also, and the part programming is given more number of examples in this textbook. And finally, almost all the definitions and the text is unique in its nature, and the examples given in this textbook is also unique and framed by myself, and all the contents are specific to suit undergraduate level and diploma level. I suggest to purchase this textbook, which will really helpful to you. Thank you, one and all.